welcome. You should be on page 20 of your quarter 3 Algebra 1 notebook. In this lesson, we're going to just start talking about polynomials. We're going to be using a lot of this information in our next unit when we multiply, divide, add, and subtract polynomials. So I think it's important to know what a polynomial is. A polynomial is an expression consisting of variables and coefficients. These are otherwise known as terms. You learned that word in previous math classes. So here's an example of a polynomial: 5x cubed minus 2x squared plus 6x minus 4. We're going to look at this polynomial, and in this particular lesson, we'll learn to answer the following question. The first question, and this should seem familiar, is how many terms? I've got term 1, 2, 3, and 4. There are 4 terms. What might not, sorry, that looks like a bigger M. We'll just erase that and make it look like the word terms. What is the leading coefficient? So remember, the coefficient is the number with the variable. The leading coefficient is going to be your first coefficient. So my first coefficient is this number here, 5. And now we need to know what it means by what is the highest degree of the polynomial. This refers to the exponent. So what is the largest exponent of this polynomial? And I see that 3 is the largest. So the highest degree of this particular polynomial is 3. Let's break this down a little. We can classify polynomials by degrees and terms. When I classify polynomials by degrees, I'm talking about the exponents. So remember, this is by the exponents. An exponent of 0 is represented by a constant. For example, 8. 8 is a constant. That is an exponent of 0. And think about it. Any variable to the power of 0 is 1. So if I had 8x to the 0, that would be 8 times 1, which is just 8. An exponent with an exponent of 1, of course, I don't really write it, so I might write 5x. This is linear. So we worked a lot with linear equations, and you've noted that when you graph linear equations, they don't have exponents higher than 1. An exponent of 2, we'll begin working with later in the year, are called quadratics. And here is an example, 9x squared. Exponents of 3 are called cubics. And, well, how about 4x cubed? Exponents of 4 are called quartic. Maybe negative 5x to the 4th. And anything of 4 or 5 or more, you're going to say to the nth degree. So if it's a 5, you'd say to the 5th degree. If it's a 6, the 6th degree, 7th degree. So maybe like 6, that's the 5th degree. So that's classifying your polynomials by degree. Classifying your polynomials by term is where we're going to really talk about that word polynomial. If it has one term, for instance, maybe like a 4 or an x or a 3x squared, that is called a monomial. And the nice things about these words is they have within them their meaning. Mono equals 1. 2 terms is a binomial. And I'm sure at this point you've learned that bi equals 2. So an example would be 5x cubed minus 4. That is a 2-term expression. 3 terms is a trinomial. And again, I'm sure you know at this time, by this point, that I forgot to put the bi. That looks like the y-intercept, don't I? Doesn't it? Tri equals 3. So maybe 6x squared minus 3x plus 2. And finally, 4 or more. Here is where I bring in the word polynomial. And this word poly means this root, poly equals many. So it's many terms. 8x cubed minus 6x squared plus 4x minus 5. 4 or more. Let's go on to our next page and see what we might do with this information. I go to page 21 now. We are going to classify the following by degree. So we're going to look at those exponents and term. Excuse me. 6x cubed minus 9x. I can see very clearly when I classify this by term that there are two terms, right? And that is a binomial. When I look at the degree, I'm looking for the highest degree. So when I classify by degree, I'm looking for the highest or the greatest degree. And of course, by term, you already know that it's the number of terms. So the degree, let's see, the highest degree is the 3. And you might remember that a third degree polynomial is cubic. This next one, I have 1, 2, 3 terms. So by term, I have 3 terms, and that is a trinomial. My highest degree does seem to be a 2, and that is quadratic. Alrighty. Sorry, I like to have everything look the same. In this C, I only have 1 term. So there is 1 term there. That is a monomial. And the degree is a 4. There's only 1 degree there. And that, if you remember, is quartic. I'm going to make sure I'm spelling that correctly. Yep, Q-A-R-T-I-C. Now this next one is also a monomial, right? There's only 1 term there, the 8. So this is a monomial. But you might say, oh no, what's that degree? Well, remember, if it's just a constant there, that's a degree of 0, and that is called a constant. When I look at E, I see 2 terms. So I have another binomial. And then I don't see, of course, my exponent there, and that's the invisible 1. So the degree is a 1, and we know that is linear. I'll just write that in red now. And my final example here is, let's count them, 1, 2, 3, 4. 4 or more, we finally got to a polynomial. And it looks like my highest term or degree or exponent is a 6. So that is the 6th degree. Anything above 4 just is the number degree. Alrighty, a couple multiple choice and then we are done. Which of the following represents a polynomial in standard form? Well, it'd be helpful to know what that means, huh? A polynomial in standard form, the degrees are listed from greatest to least. So you want to have 4, 3, 2, 1. This one has an exponent of 0, 2, 1. It's not A. C has an exponent of 2, 0, 1. Nope. B has an exponent of 1, 0, 2. D, 2, 1, 0. Your answer choice in standard form is D. Now looking at 3, name the following polynomial by its degree. I'm looking for degree, so I'm looking for the highest exponent. It's a square. Squares are quadratics. Name the following polynomial by the number of terms. There is one term. Polynomials of one term are monomials. That's it for this one. Thanks so much. Bye.